I have a project in mind that I need a 60-degree V-swage for. I do have a 60-degree swage in my big swage block, but I'd rather work at the anvil. So that's today's project, is to make a V-swage for the anvil. Problem is, to do that, I need a V-fuller. So I use the swage block to forge a V-fuller, then the V-fuller to forge a swage to fit at the anvil. And for the fuller, I'm going to start with a piece of S7 round bar. I went back to the power hammer and drew a little bit more of this out to make the swage just a bit longer. Just a little bit out of alignment, so let's see if we can straighten that. It's getting better. In hindsight, it might have been easier to start with a bigger bar and just grind the whole thing. Well, I think we're getting better, but it's not perfect. So there'll still be a fair amount of grinding to do. Okay, I've spent another half hour or so messing around with this. I think this is about as good as I'm going to get it. I'm down below the top surface of the swage block, so it's getting kind of hard to hammer in there. I'm having to use the peen, but it is filling that swage. So I'm going to put this in the vermiculite and let it slow cool. S7 is air hardening. You can't normalize it. You leave it out in air. It just hardens. While the fuller cools, I'll get started on the swage, get the hardy shank drawn out. I'm going to start with a piece of 1 3/4 inch 4140 for this, and I'll cut it 3 inches long. I'm going to establish the hardy shank using the hydraulic press, but I'm going to sneak up on the final fit under the power hammer. Then back to the hydraulic press to set this shoulder down nice and clean. I don't really need this full width, so I'm going to see if I can draw this out a little bit sideways and make a longer, narrower switch. I'll need to go back and clean up this shoulder, but at this point I want to make sure it fits the hardy hole in the anvil as precisely as possible. So I'm going to do this at the anvil. It has a little twist in it, so I'll see if I can straighten that out before I go too much further. I'm just going to put a chisel line down the center of it, start to split it open that way, and just use the fuller to define the final shape. I think I'll go ahead and switch to a fatter chisel so this spreads a little bit more as I'm cutting. Better put my touch mark in this before I forget. Okay, now it's time to put this aside and get back to work on the fuller so we can make this the right shape. Interestingly, this is awfully close, just going off of this kind of fat hot cut. It may turn out I didn't really need that fuller at all, but we'll still finish it and we'll still use it. This is the perfect opportunity to give a shout out to Blacksmith Supply and thank them for sponsoring today's video. Just about anything you need as you explore the art and the craft of blacksmithing is available at Blacksmith Supply. The Smith and Magician that we see used so often is carried by Blacksmith Supply along with an assortment of dies to fit it. They have forges, they have hydraulic presses, they have treadle hammers, as well as several different brands of anvils. Now, a lot of you have asked in the past, where do you get those tongs with the ball ends on them? Now, these ball ends help keep your hand from sliding off, kind of help balance the tongs a little bit. And these were designed by Tom Clark. They're called Tom Tongs. And Blacksmith Supply carries Tom Tongs. So you can get a wide arrangement of tongs from Blacksmith Supply, from the pickup tongs that I've been using, working under the hydraulic press and the power hammer, box jaw tongs, V-bit tongs, bolt jaw tongs, wolf jaw tongs. All sorts of tongs are available in that line of Tom Tongs. They're affordable enough that you can buy tongs and spend your time forging the other things you need to forge. Nothing wrong with making tongs. I strongly advocate everybody to learn to make tongs. But if you're just starting out or if you're too busy to make tongs, Tom Tongs are a good option for you. Now let's go ahead and cut this fuller off the bar and see if we can make a useful tool out of it. So I got that ground clean. The next step is to put this on a handle, and I'm going to use some flat bar, and it'll just weld to the top of this, so that gives a softer striking surface, plus allows this to drive deeper down into the workpiece if it needs to. I've gone ahead and welded to the handle. The next step is just to go ahead and harden it and temper it. S7's air hardening steel, and it has a critical temperature that's pretty high. So I'm going to bring it up to a good orange heat, set it aside, let it air cool, then we'll temper it and hopefully finish this swage. And since most of that doesn't need me to watch it the whole time, I thought I'd explain why I'm making a 60-degree V-swage. The project at hand is to actually weld up some steel cable. When you weld cable up, it wants to go everywhere. It just wants to spread out. It doesn't behave. And if you trap it in a swage, it welds up much better. A regular 90-degree swage is pretty darn good for that. Welding at the step of the anvil works. A round swage that's the right size would work. But the 60-degree V-swage has the theoretical advantage that all of the energy is transmitting to a single point at the center of the cable, because the swage forms two sides of the equilateral triangle and the hammer face striking it forwards the third. And as you rotate it, you're transferring all that energy to the middle, and it keeps the cable under control, tightens it up, makes the welds go much smoother. We'll find out next week if that theory is correct. The 60-degree V-fuller is ready to go. Let's go back over to the hydraulic press and see if we can finish this job in one last squish. Just want to make sure there are no sharp edges, so I'm knocking down the crisp edges. Probably do a little bit of work on the grinder before we use this. Now this is 4140, you can harden and temper this, but it is so tough the way it is that I just don't think I need to worry about it. I make a lot of things like this out of mild steel, so the 4140 is an upgrade already. And if it starts to show some wear that I don't like, I can clean it up, harden and temper it later. But that is just the right size for this piece of cable. So I think we're going to be in good shape there when we get to welding this up. Unfortunately, it's not just the right size for this piece of cable. So I may still have to go to the swage block and bend over to that lower swage block to weld up this really big stuff. And I think we're going to need some of this. We'll probably use this swage for the smaller stuff at the anvil because it cools off a little bit faster. And then I can deal with the other stuff. And by the time this is completely welded up, it's going to be a lot smaller. So sometimes you have to spend a little bit of your time to make a tool, to make the tool you need to make the other tool. I do hope you enjoyed the video. If you did, be sure to give it a thumbs up. If you haven't done so already, I would love it if you hit that subscribe button down there. It doesn't cost anything to subscribe to a YouTube channel. In the meantime, I hope you have time in your day to get out to your shop, make something, stay safe, wear your safety glasses. We'll see you for the next video.